Hello and happy Wednesday. Thank you for tuning in to this talk on MyRocks, a 30,000 foot view. I hope everyone is enjoying the conference so far and enjoying our online format again this year. So a little bit about me. My name is Mike Benshoof. I am a technical account manager at Percona. Prior to that, I was on the consulting team, so I've been around Percona for quite some time now. So, but really enough about me. Let's get into what this talk is going to be about. So really, what we're trying to go over here in this talk today, the goal is to be a high-level review of the MyRocks storage engine to maybe introduce it to you, give you a little bit more information if it's something you've heard of, and really look at the MyRocks storage engine from a high-level perspective. We're going to go over some of the pros and cons of MyRocks and where it's a good fit potentially. Review some possible use cases where it may be a good fit for your business. Really, the main thing that we want to take away from this talk is we would like to have an alternative approach when we are dealing with growing data, right? Growing data and data growth is not a new problem, but is a problem that continues to exist. And so what we want to consider here is that MyRocks is an alternative. It's not the end-all solution, but it's something that we can look at as an option when we're dealing with our growing data. In terms of what this talk is not, right? I do not mean this to be a deep dive into the MyRocks internals. We're not going to go over, the algorithms used and how everything works. We're not going to talk about the specifics of SST compactions and how we can do that. We're not going to go through all the different tuning that we can do and on all the different settings that we can work with. We're also not going to talk about a full migration process, right? We're not saying this is exactly how you need to get from InnoDB to MyRocks. The main thing, again, that I also don't want to be a takeaway is that the second this slide deck is over, that it's like, okay, now we need to migrate fully from InnoDB to MyRocks. That's not what we're trying to achieve. Again, the goal of this talk is to give you, present MyRocks as an alternative when dealing with these growing space situations. So without further ado, let's jump into it and kind of go through the MyRocks engine and start looking at it from a high level. So what is MyRocks? You may be wondering. So what it is a MySQL storage engine that's built on RocksDB. A lot of times we hear that people bounce between RocksDB, MyRocks. So MyRocks is the actual storage engine. RocksDB is the key value store that it is using under the hood to store data that's then accessible through MySQL. So the MyRocks engine was originally developed and open sourced by Facebook. Now we have builds available and packaged with Percona Server for MySQL and also MariaDB. When it was being designed, the real goal was designed to optimize space, write efficiency, and database storage costs, right? Because those are the three things that really we're looking at when we're dealing with space issues. So utilization, we'd like to have a smaller disk footprint, and MyRocks is something that can help with that. Write efficiency, so there's a term called write amplification. We're trying to minimize that and extend the longevity of our disks, while also giving us better performance by minimizing the actual IOPS that need to be done. When you combine less space being used plus a longer lifetime, that gives you a lower total cost of ownership towards your storage footprint. And as far as what MyRocks and RocksDB is, it's an LSM tree-based database engine. Okay, so I said that, it sounded like a lot of words, great. So what does that actually mean? And why does this matter in terms of storage and these other pieces that we talked about, optimization? So I know at the beginning, I said I'm not gonna go through a bunch of deep specifics and hardcore details, but just to understand why we're talking about MyRocks, I need to give a few slides just on some high-level technical details. So bear with me. So from the key paper in 1996 that introduced the LSM trees, we see some key parts from the initial abstract, right? So when we look at those, we're talking about, we can break down these 3 key points from the abstract with 3 simple pieces. So the first section, right, we're talking about an algorithm that defers and batches index changes, et cetera, in an efficient manner reminiscent of a merge sort. So what we're saying here, this is a write optimized storage engine. That's what we're trying to take away from that paragraph. Then we also talk about reduced disk movements, and especially when compared to traditional B trees, and that improves the cost performance, right? So again, here we get down to lower storage costs, right? So we can take these large chunks from the abstract and break them down, and they kind of align to what we talked about there in terms of the value and the design choices and why we did that. The final one, and this is the big caveat that we want to get through eventually, is that indexed finds requiring responses will actually lose IO efficiency, right? And so we are more useful in applications where inserts are more common, right? What does that mean? We have additional read overhead. So this is a write optimized storage engine, and we're not looking at it to benefit our read performance. So to compare it to InnoDB, right? That's what everyone normally wants to do here. It's not taken in a vacuum. It's generally compared against InnoDB. We just need to understand a little bit at the high level of the traditional B+ tree, right? If anyone has been around InnoDB for any length of time, this is probably all review, but just to go through it, the original InnoDB engine and the B+ tree itself were optimized for small random reads, right? When we think of transactional systems, we're doing a lot of small writes and a lot of small reads, right? And the random reads and the random nature of these reads, what you want is wide and shallow tables. So if I need to do a lookup and I need to do a lookup from disk, I'm not traversing the tree as far, right? I'd much rather be wide out and a very shallow tree as opposed to a tall tree. And this again is why the B+ tree was optimized for reads. So when we look at optimized for reads, that can translate to writes can also be more expensive, right? When we think about a tree, if you touch back into some of the high level parts of a tree, if you ever remember in your intro to computer science class when we talked about rebalancing a tree and all of the moves, you have a best case scenario where you just do an insert and a leaf node goes in. Well, you get that one where you have to rebalance the entire tree. Those are expensive operations, right? And with the B+ tree, we also have clustered indexing. So we have pointers back to the main records from our secondary indexes. Again, this isn't new information, but just to kind of break down, here's the structure of a typical B+ tree record, right? We have our root node, which is pointing down to leaf nodes. Those leaf nodes have pointers between them. So that is a benefit for ascending and descending scans. We're able to just scan through our leaf nodes with those pointers. And again, as we continue to get more data, this just becomes a wider tree, but we keep our depth short, which is beneficial for random reads. So now when we look at the LSM tree-based engine, so now we're thinking RocksDB, this was actually designed and optimized for write throughput. So as we are getting more data and data explodes, right, we're trying to optimize this for writes. And so the way that it works, as opposed to inserting into the tree, we have intermediate files that are merged and compacted at different levels, right? And these are compacted, these are sorted, basically sorted lists, and you can combine them with a algorithm similar to a merge sort, right? And so what we're trying to do, the real goal from an LSM tree-based engine is to convert these random writes at the engine level to append only writes that are sequential when we get down to disk, right? And so the way that it handles this is we do our random writes to a mutable mem table. Those become immutable, and then we start to flush those down to disk, and we combine these SSTs through various compactions until we're able to basically flip those random writes into sequential writes and really increase our performance that way and really design it for writing. So, the common thing that we hear when we talk about this is, well, my database instance is really, really big. I do lots of writes. Let's get ready to migrate. So, that may sound good. And this sounds, everyone writes a lot of data or wants to be writing a lot of data. But we do need to go ahead and look at, is MyRocks the right fit? So a question that I get asked from time to time. So MyRocks, is it just a better, or InnoDB plus, right? And the answer really is no. Yes, it can be dropped in, and you can alter your table and switch your table from InnoDB to MyRocks. However, there are benefits and disadvantages to doing that, right? MyRocks is not just a generic drop-in better InnoDB. It's workload and use case dependent. So from there, let's take a look at some of the pros and cons of MyRocks, and especially when compared to InnoDB. So in the pros column, right, we have LZ4 as the default compression. And because the SST files are first sorted in memory and then flushed to disk, by the time they're flushed to disk, they're 100% filled. So that gives me better space utilization. And that in turn leads us to a smaller overall disk footprint, right? So that would be definitely a pro when we're looking at exploding data sizes. Being a write optimized database, and where this comes into play, and we have some graphs later that we can show you, but the write performance becomes relatively stable and steady when the data is larger than memory, right? When we talk about InnoDB, oh, I'm hitting performance problems, just give it more memory, give it a larger buffer pool, and we're good. So we get to a point though where we can't continue to keep our data set smaller than memory, and this is where the write optimized database comes into play. Similarly, because we talked about the write amplification and we talked about additional writes and MyRocks being designed to minimize that, this allows us to use cheaper storage, right, or less expensive storage for write intensive workloads. And so again, we talk about cloud storage. If you've looked at the prices of different, for an example, Amazon EBS volumes, right, in AWS, there are volumes that can provide you ridiculously high numbers of IOPS, but they're not cheap, right? So if you can do that on a smaller, more generic SSD, than a high-end provisioned IOPS at EBS volume, that's going to save you money in the long run. And then another pro is that it's just available by default in Percona Server 5.7 and 8.0, right? So if you already are running Percona Server for MySQL in 5.7 or 8.0, you can simply enable the engine and you're off and running and ready to use it. Now, as we have a pros column, we also have a cons column. So let's take a look through there. So statement-based replication is not supported. Now, a lot of people are already using row-based, so sometimes this would not be a problem, but it is definitely something to note that statement-based replication is not supported. There's also no gap locking, which means that we do have the potential for some phantom reads. So there are ways that you can turn on additional logging within MyRocks that can identify if you have gap locking, but that is something that if your application depends on it, that can be a problem. There is no foreign key support, and myself included in this sub point that we may put this in the pro column. I'm not a big fan of using foreign keys, but if your application does depend on foreign keys, that's something to consider. Overall, it's going to be a generally slower read performance than InnoDB, especially when you have memory allocation, right? If I was able to put my whole data set in memory, it's going to be faster to read it from InnoDB. Now, order by ascending or descending have different performance characteristics. So this was something that I mentioned back in the B plus tree, right? We had doubly linked lists that were pointed forwards and backwards, which allowed us to do those scans. Within MyRocks and the way it's implemented, either order by ascending or order by descending would be fast and the other would be slow. By default, ascending is faster and descending is slower. You can flip that, but if you do that, then descending is going to be the fast one with ascending being slow. Again, there's more details under the hood, but just at a high level, that is a performance characteristic that should be noted. And then range scans and table scans are notably slower. This is something to consider as well. If your application is very heavy on scans, this may not be the best fit. And then just a few additional features that are available in InnoDB: transportable table spaces, spatial indexes, full text indexes. They are not supported in MyRocks. So I had mentioned the consistent write throughput and what we're looking at through there. This graph, based on some benchmarks by Vadim, really can show us here that as we continue to add memory to InnoDB, once we have that whole data set in memory, InnoDB will outperform. But if we look at this, right, when we have our data set notably larger than the memory available, right, which also, as we see here, the InnoDB data size was 90 gigs, while the MyRocks data size was 20 gigs using the same data set. So that also will tell you something. But notice when we get up to 90, there's no, where memory, our full data set is in memory, and our transactions per second stays steady. But until we got the majority of it in, right, we hit this tipping point in the middle, and that's when all of a sudden InnoDB would outperform MyRocks. But we're looking at a data set that's under 100 gigs. When you're talking about a multiple terabyte, we don't want to have a terabyte buffer pool or a terabyte of memory available. And this is where MyRocks can begin to shine. So we see here, right, we have steady performance. There's a little bit more performance as we add more memory, but it is allowing us to keep that higher throughput when our data well exceeds the memory available. Then we also talked about I/O utilization, right? So we talked about read amplification and write amplification. I mentioned both of those. So on the graph on the left, we can see how InnoDB compared to MyRocks, when we were doing the writes, MyRocks is always doing fewer kilobytes of writes, so fewer IOPS per transaction, right? And so this was, again, based on these same benchmarks by Vadim and the raw data that's shared there at that link if you're interested. And so what we're seeing here is that, again, InnoDB improves as we get more of our data set in memory. It never really reaches the same throughput, though, and the same I/O utilization as MyRocks does. Now, on the reads side, right, again, when we have our data size well above the amount of memory, MyRocks is outperforming it. But similar to the previous slide where we showed the throughput, once the data set was primarily in memory, InnoDB can outshine. And again, this is where InnoDB, if we recall, was based on the B+ tree. So it is going to be optimized for small reads, which we can see right here. Once our data set fits in memory, now the read amplification is next to, hardly exists when we're looking at it from the InnoDB side, whereas MyRocks, again, stays flat. So more data than memory, you're going to have less read amplification, and you're going to see better performance within the MyRocks side. But then once we get closer to fitting our data into memory, InnoDB can't outshine it because it was designed to be that way. So I gave a lot of graphs. I gave a lot of high-level discussion. So when does MyRocks actually make sense? So when, you've heard me use the phrase very large data sets. So when our working data set is larger than memory, this is where MyRocks can shine. And then also, if our workload is I/O bound, again, the previous slide showed the read and write amplification. So if our database and our workload is I/O bound, obviously reducing the amount of I/O pressure on our system is going to be a benefit, right? So if I am an I/O bound workload that's larger than memory, this would be a good potential case. Also, if we have limited storage hardware, right? Everyone says, well, if I can just get, faster storage, but a slow write is a slow write is a slow write. So, if we know that our writes are going to be slow, let's do less of them. Let's not make it up in quantity, right? And so that's something that MyRocks can help because we have that reduced I/O. But also similarly, if we're going to move to the cloud again, and we want to keep those cloud storage costs low. If I know that in InnoDB, I need to handle 10,000 IOPS, but I can go ahead and cut that down to 5,000 IOPS. That can get me on a cheaper tier of storage. If I know that my application is very limited in range scan queries, right? If I'm not trying to run a lot of aggregate reports and I'm really doing my point lookups, some features like Bloom filters, those can help these point lookups, but they do not help in the case where there's range scans. So again, knowing your application, knowing what your workload is, can really help to identify if MyRocks is a good fit. And finally, if we have no requirements in our application for foreign keys, full text indexes, spatial indexes, unique keys are supported, but they're a performance killer. So if I need any of those features, MyRocks probably isn't going to make sense, right? If I'm, just throwing an app out there where I'm collecting geospatial data, and I'm writing it as fast as I can because things are streaming in. It's not really great to use GIS data in MySQL unless we have spatial indexes. Well, MyRocks wouldn't be a good fit. So again, this would be something where I would look for an alternative solution. So we've gone through kind of just the high level, where it fits, the pros, the cons, where it's about. So let's look at just some actual potential use cases that we could look at for MyRocks. So if we have streaming financial data, right, this is one where, and I use the term streaming, there's other technologies, obviously, but if I need to keep it in MySQL for whatever reason, if I need to keep every transaction over a, however many year period that needs to be archived, but I may need to select individual transactions on demand, this is a case where it may fit, right? And here again, transactions are insert only, so I'm getting them written. I'm not going back and updating them later. And also, if we think about, I'm trying to capture these transactions and I need to kind of have predictable response time, even when my data outgrows it, my data outgrows my memory. This is a case where, MyRocks may be worth investigating. However, I put this caveat in here, right? If I then come back and I want to use this same table and I want to do aggregate reporting and say, okay, well, how much did this user spend in the first quarter of 2019? That query is not going to perform very well on the MyRocks side, given the fact that we're going to be scanning over a range, a date range. So if it would just be, here's a table that needs to record these items, and I'm going to need to look up, okay, what was this one transaction by primary key? Something like that could be a good fit. Another use case, kind of on a similar thing. I don't want to get too redundant here, but medical records or things that are just kind of tacked on. They're written once and then they're maintained, right? And with various regulations, we're going to require many years of historical records. And so things like this, you can't just purge this data, right? A lot of times we'll talk about archiving strategies. Well, if I need to have that data there and I need to be able to read it on demand, but several years ago, I'm going to need to not be purging that data, which means it's going to have to be stored there. And again, taking nightly snapshots, even incremental snapshots of still, relatively static data is not ideal. Things like these, these are notes and large string values, so potentially they get compressed nicely, which may also be a good fit given the compression and packing that we can see in MyRocks. Another thing, right, if I'm looking at a schema where I do have standard OLTP relational tables, I can keep those in InnoDB, but then keep this one table in MyRocks, right? We're not the best plan all the time to mix engines, but it is a possibility, right? If I want to rarely join it and be able to join it, but know that I'm just kind of streaming things into this one, large archive table, and then have my relational data as well, but I want them all in one system in case I need to do a join, and I don't really care about the performance of that, this could work. And then similarly, right, if we look at bulk loading, there's optimizations that we can do when we can set MyRocks variables and we can actually get better bulk loading performance. So if I'm constantly, importing a batch of records, that type of thing, that could be a possible use case as well. So those are some use cases. Again, I don't want to be redundant. You can think of anything, but again, the main use case and the main workflow is going to be write intensive with a large data set that outfits memory. Yeah, we don't need to go through every potential vertical and talk about how it's a fit. So last up, I want to kind of go through some operational caveats and some notes and just some things that you need to be aware of. Again, we've talked about some of the designs. So if some of those check a lot of boxes, I want to also just give some high level notes as far as, hey, this is something to consider as well. So there's no online DDL, right? So this is something that, if I need to alter a table, it's going to need to be blocking. Unless I use an external tool like PT Online Schema Change or Ghost, those are alternatives that can help. But within MyRocks itself, there is no online DDL. Again, we talked about it earlier. There is no statement-based replication. So tools like PT table checksum, they require statement-based replication. So that is something to consider if that's a requirement. If your infrastructure is already operationally using extra backup and you want to be on 5.7, extra backup is not supported for MyRocks on 5.7. So you would need to use a different hot backup option like the MyRocks hot backup tool. So again, where that's going to be important is that we're going to need the engine to be fully, we're not going to want to mix engines in that case. With 8.0, we have extra backup support, so that is much, much better. The other thing, if you're used to running metrics or doing any sort of reporting based on file names within a table space, right? If you look at file per table within MySQL, InnoDB, that gives you a single table space file for each table. That's not going to be this way, right? We're just going to have a whole directory filled with SSTs, those various levels that we talked about, and there isn't a way to just say how big is this one particular table just by looking at the disk footprint of this particular table space. And finally, just a quick note, PMM does support MyRocks. There's already predefined panels within PMM that exist. So with that being said, here is an example. I just had a sysbench test running with PMM and letting it capture the MyRocks data. Now, as you're using PMM to monitor an existing implementation, these are the types of pages that you'd look at. If you're actually using PMM more of in the evaluation phase, looking within the IO details to make sure that those graphs match what we were seeing before, right? Are you seeing less IO throughput? Are you seeing better overall query throughput? That's what we're trying to investigate. So the MyRocks pages aren't as critical in the evaluation, but once you're live, these will give you more insight that you can then use to tune your actual MyRocks configuration from that point on. So I think that was a lot of information. Just to kind of summarize it and break it down here, the final thoughts on this. So the main things that I wanted to cover fit. MyRocks is not a silver bullet, right? As DBAs or in the IT field, we always want to look for this, hey, what's this one thing that'll fix everything? MyRocks is not that, right? It's not going to fix every one of my relational database issues, right? And I always want to make sure that I use the proper technology, right? This was a talk about MyRocks, but maybe the better approach would be a different technology altogether, right? Maybe Cassandra is a better fit. Maybe MongoDB is a better fit. We don't necessarily want to say it has to be MyRocks because I have to stay in MySQL. Now, sometimes that makes more sense, right? If my whole stack is built against MySQL and I don't want to go and make all the changes necessary to support a different technology, it may fit. But you really want to make sure that you're using the proper technology, right? I mentioned the phrase streaming several times. Well, there are streaming platforms out there that we could use instead. But sometimes it's more challenging to change than it would be to just switch the engine and have a better fit from that. The next piece is that you really want to understand your workload, right? We talked about a lot of use cases. We talked about a lot of requirements that we want to make sure. We really need to make sure that we understand this. The worst thing that can happen is that you end up putting a terabyte of data into a MyRocks table, and then all of a sudden realize, oh, actually, we do need foreign keys on this table. And at that point, now you're in a big mess to try to get back. So really understanding your workload, or likewise, if I say, I do a lot of writes, but I'm actually CPU bound, well, MyRocks might not be a big help, right? This is, again, we want to understand our workload and our requirements before we go through and we choose MyRocks. So if we've gone through everything and it looks like it may be a good fit, then it's time to evaluate, right? And so I put test, and then test some more. So we don't want to ever just blindly switch. We want to understand the different performance characteristics. We want to understand the different challenges that we may face. Finally, if we do see a good fit, we can actually see good benefits, right? If the use case does fit, MyRocks can be a great option for you. And then finally, once you're there, we want to make sure that we're using PMM to monitor and evaluate, because like with everything, right, this is iterative. We're going to look for potential challenges and we're going to tune as needed. So with that being built in, that is a great tool to use once you're in production. So that's all I have. Again, this was just a high-level review. So if there's any questions, feel free to put them into the chat window here, or you can always email me after the fact, and my email is there. So thank you so much for listening, and enjoy the rest of your day.